Now we will start the numerical part. When the expression mu is equal to a plus b upon lambda square, where mu what the velocity of light in air with respect to velocity of light in glass, where lambda is the wavelength, and find the dimension of a and b. So dear students, first of all you have know the dimension of mu. What is the dimension of mu? Mu is the dimensionless. Why? Because mu is equal to velocity of light in air, velocity light in, because mu है velocity light in air, velocity of light in medium, both have a dimension meter per second. This is also meter per second. It is dimensionless. The dimension become m0, l0 and t0. If we write, then we can write as it is. Now the dimension of a, so we can say mu is equal to a plus b upon lambda square, in which mu dimension, you know, the dimensionless. Similarly the a will also dimensionless because mu will compare of them. Then dimension of a will be m0, l0 and t0. And now for dimension b, we will also say that the compare of the a, this vector dimension will equal to this vector dimension. Then dimension a is equal to b upon lambda square. Then dimension of b is equal to a into lambda square. Dimension a is dimensionless. Then we can say this is m0, l0 and t0, and L is the wavelength unit is meter square, then L2. Then we can say dimension of b is L2. Our dimension of a is m0, l0, t0, and dimension a is m0, l0 and t0. This is the dimension of a and this is the dimension of b. Of the question we have find the dimension of a and b. Now in this question, we in the expression of the equation y equal to a sin omega t minus kx, this is the equation of progressive wave. We will learn in a chapter of wave. So right now we have know the equation y equal to a sin omega t, where a is the amplitude, by the displacement, here a is amplitude. Amplitude means that if this is the wave, so you know this is called amplitude. The displacement equation is by, this is the function of by a sin, a is amplitude, sin omega t minus kx. In this case a is amplitude, find the dimension of omega and k. You know my dear students, first of all you know the dimension in the angle is in a radian form. It means that this is dimensionless, this is also in a dimensionless. Then we can say omega t is equal to m0, l0, t0. Then t is the time, then omega is equal to 1 upon t, and the dimension is t power minus 1. First. Second is dimension, find the k also. Similarly kx is equal to dimensionless, m0, l0, t0. There find the value of k here. So m0, l0, t0 upon distance is x, is displacement l. So we can say this l minus 1. And then dimension of k is l inverse, l minus 1, and dimension of omega is t minus 1. Equation second, this is equation first. Now in this case you have to know the rigid number and r is the Reynolds number. This is the Reynolds number, is depends on the rho Vd upon eta, where the rho is the density of the fluid, v is the speed of the fluid, d is the diameter of the pipe, and eta is the coefficient of viscosity of the fluid. Suppose this is the pipe, this is the diameter you have given. Suppose the water is flow in the pipe, and this is the speed of the pipe fluid in a pipe, and eta is the viscosity, means water कितना viscous है. We will learn in a chapter of fluid in next second part of the book. And d is the diameter of the pipe, eta is the coefficient of viscosity, and n are the number of Reynolds number. So we have to write the proof, the formula. The formula is right or not. Number is unitless. Number is unitless. Any number which is the unitless, then we can say the relation nr is depends on density power a, velocity power b, and eta power c, and d is the diameter of the pipe. So d we will not take, because d is the constant, fixed, it will not change. Density can maybe change because we can change the fluid, velocity can change, and viscosity can be changed, but diameter of the pipe does not change, so we will not consider the informal form. Then we will take a proportionality constant is k, and density of a, and velocity of b, viscosity of c, and d, where k in this case is, we will consider a 1. Now we know the dimension of each factor. Density dimension is, density is equal to mass upon volume. Mass dimension is m, volume dimension is l cube. Dimension what solve, m l minus 3. This is the dimension of rho. Dimension of speed, speed is equal to displacement upon time. This dimension is l, and this is the t, so we know the dimension is l t minus 1. Eta formula, find the formula of 6 pi eta rv. This is the formula of Stokes law. Then find the value of eta, f upon 6 pi rv. 6 pi is the constant. Dimension of force is m l t minus 2, and this is the l, and this is l t minus 1. Now solve them. Then eta become what, m l, this is m l t minus 2, denominator will be l2 t minus 1, and square bracket will close them. Then solve it, m l minus 1 t minus 1. This is the dimension of eta. And number, Reynolds number dimension is dimensionless, m0, l0, and t0. So we have learned all the dimension, eta, and speed, and density. Now what will we do? Put the dimension in the equation. This is the equation we can consider first. Put the dimension in equation first. We get the dimension is eta. Put the dimension of all factors, then m0, l0, t0 is equal to k. Constant is density. Dimension is density what? Density is m l minus 3 power a. Speed dimension l t minus 1 power b. Eta dimension m l minus 1 t minus 1 power c, and diameter is we can divide the l. Now we will solve them. Left side does not change. In right we will solve m power a, l to the power minus 3a, L की power b, t is minus b. Here is m is c, L is minus c, and t is minus c, and L is power 1. Now m, here is a, here is also m, base m power add. Now for L, minus 3a plus b minus c plus 1, and will be t what, here is not t, here t minus b and minus b and minus c, yeah. And LHS is m0, L0 and t0. Comparing the power we get, we will compare the power for the relation, then value will be, we will compare of them. Here is a plus c is equal to 0, equation first. Now here minus 3a plus b minus c plus 1 equal to 0, equation second, and minus b minus c is equal to 0, equation third. Here is 3 equation and 3 variables, so we can easily solve it. We can solve by solving, we get a plus c is equal to 0, then we can say a is equal to minus c, and put the value of and b from the equation, this is equation fourth, from equation third, and third में minus b is equal to c, it means that b is equal to minus c, and a is equal to minus c, b is equal to minus c, and put the value of a, b in equation second, a and b in equation second, we get minus 3c and b is equal to minus c and minus c plus 1 equal to 0, and we can say minus का 3c minus का c and minus का c plus 1 equal to 0, and minus का c and minus का c 3c, and this is minus 3a, minus minus this will come plus, this become plus 3c and c is c plus 1 equal to 0, and c is equal to minus 1, c is equal to minus 1, put the value of c here, then b is equal to plus 1, b1, put the value of c here, then a is equal to also plus 1, and we have no value of b, c and c. Put the dimension in equation first, we get proportional to the equation first is given, this equation is eta power a, then we can say eta power a and velocity power b, and eta power c and d. Put the value abc here. Density power 1, velocity power 1, or eta power minus 1 into d. So minus 1, this factor will be come out in the denominator form. Then Reynolds number proportional to आएगा rho v d upon eta.